Welcome to the lecture series Programming with Problem Solving, and today's session is going to be a talk on Pandas. Pandas, it is a powerful and widely used open source data analysis and manipulation library for Python. It provides data structure and function which are needed to work on a structured data. So we can say the features of Pandas as like data structure in terms of data manipulation and in terms of data analysis and the performance. So related to the data structure, we have the two concepts called series and data frame. Series, it's a one-dimensional labeled array which are capable of holding any data type. And data frame, it is a two-dimensional labeled data structure with columns of different types. It is like a spreadsheet or a SQL table in Python. And related to the data manipulation, we can read and write data. This Panda, it supports various data formats like CSV, Excel, SQL, and JSON. And the data handling, handling missing data, filtering, transforming data, data cleaning, that all can be done with this pandas, and the process of merging, joining, reshaping, and the data wrangling it also possible in pandas. And we can also do the data analysis with the descriptive strategies, or it can be done with grouping, or it can also be with this time series analysis. And we can look into the features of pandas. It is fast, efficient data frame object with default and customized indexing. And as I have said, it is used for the reshaping and pivoting of the data sheets, and it can be grouped for aggregations and transformations. And these are some of the key features of pandas. And the points related to this we have discussed. And um, coming to the installation part, to install Panda, we can use the pip, or we can use Anaconda. And uh, we have to import pandas as PD. And if you want to create a series, we have to import pandas as pd.series. And if you want to create a data frame, that a specific format of pd.data frame has to be used. So let me discuss a few points related to the creating of the series object. So this Panda is particularly useful when working with the structured data like CSV, Excel, SQL, and this library allows user to read and manipulate data from the source, and we can perform calculations, and the transformations can be done, and we can also generate some visualizations. So as I have said, in pandas, the most commonly used data structures are series and data frame. Series is one dimensional, and this data frame is two dimensional. And here you can see the example of Panda series. So these are the syntax we are supposed to use. Import pandas at PD, and we can give the series as 1, 2, 3, 4, 5. And if we use the syntax print data, the output, we can see the index on the left and the values on the right side. So the index, it will be starting from 0. And this is the point you have to keep in mind. And to create a series object, you are supposed to have the series syntax like this: import pandas as PD, and you can write a pd.series, and within the square brackets you can give the values, and the index values also can be given. And if we print this yes, you will get the output like this: 1, 2, 3, 4, 5. 1 is Dhoni, 2 is Virat, 3 is Rohit, and 4 is Raina. And here the data type is an object data type. And to create a series object, you have to import pandas as PD, and then you have to create a PD.series. And if we give the syntax print x dot values and print x dot index, you can see the output as 1, 2, 3, 4, 5 and the range index. Start is 0 and stop is 5, and you can see the step is 1, step value is 1. And here is the procedure to create the pandas data frame. So these are the syntax you are supposed to use. We can input pandas as PD, and in the data you can give their names as Alice, Bob, Charles, David, and the age you can give, and then gender you can give. And if you run this, you will get the output of 0, 1, 2, 3, and the name, age, and it's ended with the gender. So this is how you are supposed to create the data frame in pandas. And here one more example for this pandas data frame. And here you have the syntax input pandas at PD, and D is equal to, we have given the name inside this, and we have given the occupation, and we have used the syntax frame is equal to PD dot data frame, and as D comma columns as name and occupation. If we print, we will get the output as name and occupation. Everything is organized, and it is the output is like displayed as a frame. And some of the other simple operations with the data frames you can see, and the data is given as a food and its weight. And you can use the head function to get the first two series. So here is the syntax for that. And you can also use the tail function to get the last two series, df.tail. And here you can see in this data, you can get the first two entries, apple and banana. And if you use this df.tail, you can get the last two entries, orange and mango. And then we can also do the simple operations of accessing columns in a data frame. And we can also access rows in a data frame, and we can do various assignment on the operations on the data frame. We can add another column like that, and we can also add some of the value to the column, and a series can be also be mapped into a data frame like this. So here in this example, you can see the column, new column is added like kind. So all this, we have the data round, and again the mapping can also be done like under kind, it can be of round, long, and as per our wish we can make the mapping also. So we can also use expression to fill the value in column, and we can delete the column, and we can also have the transpose of the data frame. These are the different operations we can do with the data frames. And here comes the comparison of NumPy and pandas. Related to the fundamental data object, we under pandas we have the series and the data frame, but the NumPy it has the n-dimensional array. And this pandas it takes more memory, and NumPy it uses less memory. When compared to the performance, NumPy is faster than pandas. When comparing the performance on larger data set, pandas are faster than NumPy, and the pandas can handle heterogeneous data type, and the NumPy can handle homogeneous data type. So pandas that have the index position and index label as an access method, whereas the NumPy has the index position as an access method. So the indexing in pandas are slower, and the in NumPy it is quite faster. And the core languages which are used in pandas are Python, C, Python, and C language, but in NumPy we can use C. So the pandas, the objects are created from external data like CSV, Excel, or SQL. But in NumPy, it generally uses the data created by the user or the building functions. So coming to the application, these pandas are used for data manipulation and data branding, but NumPy are used to create matrix arrays, which are used in machine learning models. And when making a comparison between NumPy and Panda in terms of operations, they have the special utilities, but NumPy doesn't have any functionalities. And the speed is data frame handling speed is slower than array in the case of pandas, and NumPy arrays are faster than data frame. So the usage of pandas that are commonly used for holding external user data frame and perform analysis to understand the data, and this NumPy, as discussed in the previous slide, is used for ML model generation. Thank you.